Example 1. Find the sum of the first 5 terms of the arithmetic progression 7, 10, 13 and so on. Now we're only talking about 5 terms, so it's easy enough to just list the 5 terms and add them up. So 7 plus 10 plus 13 plus 16 plus 19 equals 65. The problem's not as easy if it was, say, to find the sum of the first 50 terms or the first 500 terms or 5,000 terms. There is an alternative method, and that is to find the mean of the partial sequence. In this case, we only want the first 5 terms of this sequence, and then multiply that mean by the number of terms of that partial sequence. So in this example, we can find the mean by taking the average of the first and last terms of this partial sequence. So the average of 7 and 19. So 7 plus 19 divided by 2 equals 13. And since there's 5 terms in this partial sequence, to find the partial sum, we then take the mean, multiply it by 5, since there's 5 terms, and that gives 65. Example 2. Find the sum of the first 500 terms of the arithmetic progression 7, 10, 13, and so on. Now this is similar to example 1. The only change is that instead of the first 5 terms, we're looking at the sum of the first 500 terms. And we're going to use the alternative method. That is, we find the average or the mean of the first and last terms of the partial sequence and then multiply it by the number of terms of the partial sequence to then find the sum of that sequence. So the first term of the sequence is 7. Now the last term of the partial sequence, that's the 500th term, T500, is equal to 7 plus 499 multiplied by 3. So that's the A plus N minus 1D, and that equals 1,504. So the partial sum of the arithmetic progression is equal to 7 plus 1,504 divided by 2. So that's the average of the first and last terms, multiplied by 500, because that's the number of terms that we want to add together, first 500. And that equals 377,750. Example 3. Find the sum of the arithmetic progression 3, 7, 11, all the way up to 4,815. Now in this example, we know the first term, we know the last term, we know the common difference, which is 4, but we don't know the number of terms. So the first thing we need to determine is how many terms are there in this partial sequence. Once we have that, we can then determine the partial sum of this arithmetic progression. So let's determine n first. So Tn is equal to 4,815. So I go straight to the last term and determine what value of n would give me the last term. So 4,815 is equal to 3 plus n minus 1 times 4. And we're going to solve for n. So this is the formula for the general term or the nth term of an arithmetic progression. Subtracting 3 from both sides, 4,812 is equal to n minus 1 in brackets multiplied by 4. Dividing both sides by 4, we have 1,203 is equal to n minus 1. Adding 1 to both sides, we have n is equal to 1,204. So there are 1,204 terms in this arithmetic progression that we want to add together. So the partial sum of the first 1,204 terms of this arithmetic progression is found by taking the average of the first and last terms and then multiplying it by the number of terms. So 3 plus 4,815 divided by 2 multiplied by 1,204, and that equals 2,900,436. Example 4. Find the sum of the first n terms of the arithmetic progression A plus D, A plus 2D, and so on. Now the first term of this AP is A, and the last term is A plus n minus 1D. There are n terms that we're going to add together in this arithmetic progression. So let's use the same formula that we used in the previous examples. That is, the partial sum is found by taking the average of the first and last terms and then multiply it by the number of terms that we're going to add together. So the partial sum is equal to A plus n minus 1D, so first and last terms, an average of those two. Multiply that by n, and we get n over 2 outside of A plus n minus 1D. So that n over 2 just comes from this n and this 2 here. So I'll just put them out at the front. And combining the two a's together, we get partial sum equals n over 2 outside of 2a plus n minus 1d in brackets. And this is the alternative formula to the sum equals the average of the first and last terms multiplied by the number of terms in the sum. Example 5. Given the arithmetic series 100 plus 94 plus 88 and so on, find S41. Now S41 represents the sum of the first 41 terms of this series. And we're going to use the alternative formula, Sn equals n over 2 outside of 2a plus n minus 1d. And the advantage of this formula is that you don't need to find the last term explicitly so that you can average it with the first term and then multiply it by the number of terms. It's built into this formula. Now a equals 100, we know that. D is equal to negative 6, that's a common difference. And we're going to sum the first 41 terms. So substituting these three values into the formula, we have S41 is equal to 41 over 2 outside of 2 times 100 plus 40 times negative 6, that's the n minus 1 there, and that equals negative 820. Example 6. Given the arithmetic series 40 plus 37 plus 34 and so on, find the least value of n for which the partial sum is negative. Now the strategy here is we're going to solve the inequality for n over 2 outside of 2a plus n minus 1d less than 0. The left-hand side represents the sum of the first n terms of this arithmetic series. So we want to find the smallest value of n such that the sum is negative. Now we know that a equals 40, it's the first term of this series, and the common difference is negative 3. So substituting these two values into the left-hand side, we have n over 2 outside of 2 times 40 plus n minus 1 times negative 3 is less than 0. We can multiply both sides by 2 and we can multiply the 2 and the 40 together and just clean it up a little bit. We get n outside of 80 minus 3 outside of n minus 1 in brackets less than 0. Now expanding the inner bracket there, we have n outside of 83 minus 3n less than 0. And if we divide everything by 3, we have n outside of 83 over 3 minus n less than 0. So therefore, n has to be greater than 83 over 3 or greater than 27 and 2/3. Hence, the first integer that's greater than 27 and 2/3 is 28. So therefore, S28 is the first sum that is negative.